Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 28 of our 30 LeetCode challenge, and the problem that has been given to us today is the first unique number problem. If you want to try solving this problem on your own, you can pause this video and find the LeetCode link in the description below. So let's just get started. So the problem description is that you have a queue of integers and you need to retrieve the first unique integer in the queue. Basically implement a first unique class. A first unique class has a constructor which passes in a bunch of numbers. Show first unique, which basically returns the first unique integer of the queue and returns -1 if there's no such queue, and an add function which basically inserts a value to the queue. So you can sort of look at this input and the output. It's pretty straightforward. There's not really that much into it. So the explanation is that you call the first unique, which sort of, initializes your queue, and you pass in some values. So you have 2, 3, 5 coming over here. Then you call the show first unique, and the show first unique is going to return the first unique value. So the first unique value inside this queue is 2. So you return that. You have an add function which adds, in this scenario, it's adding a 5. So when you add a 5, the queue becomes 2, 3, 5, 5. So 5 no longer becomes a unique value. So it can never be a unique value anymore. But 2 still becomes our first unique value. Then you have an add function again, and if you call the add, which is adding 2, then 2 is no longer our unique value because it's coming over here, and 3 basically becomes our next first unique value. And this basically goes on for some more time. So this is a pretty straightforward problem, and most of you would already know, like whenever you have a queue implementation or strategy that you want to use like that, it becomes a lot more easier for you to use just a simple queue, or in this scenario, you could actually use a doubly linked list with a hash map to maintain the number of counters. But we don't really need to do that because we know for a fact that in Python, we have this awesome collections module which has the order dictionary, which basically maintains the order. If you don't know what order dictionary is, you can find some of my previous videos where I sort of elaborate how it works. But internally, it's using a doubly linked list with a hash map, and we can just use that. So time complexity of an order dictionary is going to be O of 1 for get operations and delete operations, and that's what we want. So let's just go ahead and start with our implementation, and we're just going to initialize a few variables. So I'm just going to make self.nums equal to ordered dictionary. And what I'm going to do is I'm also going to create something as a gatekeeper. Now, the reason I'm sort of doing that is because I don't want my self.nums to handle operations of insertions and conditional checks at least. So all those conditions are going to be looked at by something called as self.counter. This just makes it a lot more easier and a lot more flexible on how I can leverage everything else. So I'm just going to pass in nums inside this collections on counters. So self counter should now have the count of all the numbers which are being passed in as a list. So now if I do a quick iteration, and if I do for num and nums, if the self.counter is equal to num, sorry, is equal to 1, well, in that case, what it sort of dictates is that this particular number which has been passed in is unique so far. So we can sort of append that or sort of insert that to a self.nums. So I can just say self.nums, num, and I'm just going to give it equal to true. So all we're doing over here that we should note is that the counter is our gatekeeper, just to make it a little interesting, and self.nums is nothing but our queue, our ordered queue. Well, in a way, which does operations in a very fast manner. So there are a few things that you need to look at. So the show first unique operation is pretty straightforward. There's not really that much into it. So if you think about it, you can just say, hey, if you don't really have anything inside, if you don't really have anything inside your self.nums, which is your order dictionary, then basically you return the -1. Otherwise, what you want to do is you want to return the first element inside self.nums. There are a couple of ways of doing that. The way I like to do it is just convert it into an iter object and just pass self.nums inside of it and call the next. So that's just going to call the first value. This is going to take off 1, so we don't really need to worry about time complexity at least. And this operation happens in O1 time complexity. The add operation is where we have to be a little bit careful. So do note that we're using a gatekeeper, and let's leverage that. So there are a few conditions that we need to take care of. The first condition would be if self.counter does not really have any value, as value sort of stated inside. If that's the case, then we can go ahead and insert that inside our self.nums, which is an ordered dictionary. If there is already one existing value inside this thing, then we can pop that out. And if it's already greater than, if the self.counter is already greater than 1 for this particular value, then we don't really need to do anything. We don't need to insert it anymore. So let's just go ahead and let's quickly do that. So the way we can do that is just by saying self.counter value, which is being passed in. If it's greater than 1, then do a simple return. No need to do anything else. Else if, I'm just putting an else if even though it's not really required, but just to make it like, a little bit more readable. So I'm just saying the next condition is if that self.counter value is equal to 1, well, in that case, what that means is that that value should ideally be inside self.nums as well. So let's just go do a quick check over here and say that, and the value should also be inside self.nums. This is just for safety. So if that's the case, then we just need to remove self.nums because it's going to now, it's going to start repeating now. So when we do this delete operation, we don't really need to worry about anything else. It's going to get deleted automatically. And the last condition is just going to be if this value is not inside self.counter and self.counter is equal to 0 for this particular value. Well, in that case, we can just set our counter. That's the first thing that we must do because this is our gatekeeper and it needs to be informed. And self.nums value can also be passed in, and I'm just going to give it true. So it doesn't really matter what I give it. It's pretty straightforward. So all we have done over here is just handle a bunch of conditions, and do note that we're not handling everything inside self.nums itself, even though you could, but that would just make things a little complicated. We're using a counter to use it as a gatekeeper and just identify all these things. Cool, so let's just go ahead and run this problem. Hopefully this should run fine. And let's just go ahead and submit this. Hopefully it should get submitted as well. And also we can see that the solution has been accepted and there are no issues whatsoever. Do note that we are running with a time complexity of O of n in this particular scenario, but apart from that, everything else is running in O of 1. Cool. So that was it for today's video. If you have any doubts, if you have any comments, do leave it in the comment section below and I'll try to get back to you as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.